Drashti Parikh and this is my video submission for assignment 3. My student ID is 1014198828. In this video, I'll walk you through the key parts of the assignment, including the code implementation, results, and answer to the provided questions. The part A includes the image convolution. So, convolution is a method and it's a mathematical operation used in image processing to extract features such as edges, lines, and textures from an image. In part A of this assignment, we applied different kernels to a car image to detect specific patterns like 45-degree lines, 135-degree lines, and edges. So as you can see here, I'll run it. Okay, I forgot to run the imports. It's run. I'll just run all of the cells above. So yeah, as you can see, this one is the one with the inclination to 45 degrees, and next up, as you can see here, the 45-degree line detection and the original image. This one is the 135-degree line detection. You can compare the images as well. And now we'll move on to the question 2a, which is show code. Here is the code where I created kernels for detecting 45 degrees and 135-degree lines. After applying these kernels using the convolution, the resulting images highlighted the respective patterns in the car image. You can see the difference. Yeah, over here. So now as the results, we can say that the convolution outputs clearly show how different kernels emphasize specific features in the image. Now we'll move to the part B. We'll start with the importing libraries. So for part B, I've used the CIFAR10 dataset, which consists of 60,000 images across 10 classes. The dataset was pre-processed by normalizing pixel values to a range of 0 and 1 and 1 hot encoded labels. So next is the building the neutral network model. And the original model had one convolutional layer followed by the max pooling, flattening, and 2 dense layers. It achieved a training accuracy of 94.47%. So as you can see here, I've trained the model, and you can see the plot here. You can see the difference between training accuracy and the validation accuracy. Next, I added the 2 more convolution layers to create a bigger model. While this increased training accuracy further, validation accuracy did not improve significantly, indicating that overfitting was pre-persist. The dropout layer as well. To address overfitting, I added 2 dropout layers after each convolutional layer and before the output dense layer. Dropout randomly deactivates the neurons during the training to prevent reliance on specific neurons and improve the generalization. Next, as you can see the accuracy curves. Here is a plot showing training and validation accuracy for the model with dropout layers. You can see the graph. As you can see, dropout reduced overfitting slightly by narrowing the gap between training and validation accuracy curves. So yeah, that was all. Now let me move to the question 3. Just wait a minute. So yeah, the question saying that did the network present signs of overfitting? If so, in which epoch? Yes, the original model shows signs of overfitting starting around epoch 10 to 15 when validation accuracy plateaued while training accuracy continued increasing. So next question was write down how many layers this model has and identify their types. So the original model had 5 layers, one convolutional layer for feature extraction, one max pooling layer for dimensionality reduction, and one flattened layer for reshaping data into vector format, and two dense layers for learning patterns and classification. Question 5. Briefly explain what is the purpose of each of those layers. So each layer serves a specific purpose. Convolutional layers extract features, pooling layer reduce dimensions, flatten layers prepare data for dense layers, and the dense layers learn patterns and classify the outputs. Next is the question 6, which is add one or more convolutional layers to your model and run it again. It really took a long time, but adding an extra convolutional layers increased the training accuracy but did not significantly improve the validation accuracy due to persist overfitting. So I'll go to the question 8 and 9. It says to add a dropout layer to your model and compare the result with the previous one. And the question 9 itself, explain with your own words what is the purpose of the dropout layer and how it works. So dropout layers helped me to reduce the overfitting by forcing neurons to learn reductant representations instead of relying on specific neurons. So to summarize, this assignment helped me to understand the convolutional operations in image processing and how neural networks can be optimized using techniques like adding layers and dropout regularization. So thank you for watching my submission.